Welcome to the next episode about Rx. Today we'll be discussing schedulers and how to parameterize concurrency. So previously we've talked about the observable and link aspects of Rx, which allows you to represent asynchronous data streams and to query them. Now we're going to talk about the parameterizing concurrency part. In particular, you should note that since these data streams are asynchronous, that means there is concurrency that's potentially involved. And that means you have to be able to parameterize it so you can say where the concurrency is created. All right, so for example, I have a timer here that we've asked to fire every 5 seconds. And the problem is, which timer do I use? There's actually a lot of timers in dotnet. I could use any one of these timers. I could use the threading timer, the timers timer, Windows Forms timer, the dispatcher timer, and so on. Sleeps on the current thread, even remote machines. And so which timer does Rx use? And actually, a lot of people kind of wonder that kind of question. The answer is, well, we pick a default that we think is reasonable. In this case, we actually use the threading timer as the default. But we actually allow you to parameterize where it happens. The way we allow you to parameterize it is via schedulers. A scheduler really is just a box that has 3 components to it. First, the ability to do work. That's the execution context. There's an execution policy about in which order you do work. And the last thing is it's a clock. And that's kind of the least obvious of the 3. So a clock actually is important because if you ask to do work at a particular time, it matters what the scheduler's notion of time is. So for most cases, most of the timers I showed you previously, for example, run on the local machine. But if your machine is on a remote machine, or like in outer space running on some satellite, it might actually have a significant time difference from you. And so to have a clock is actually a really important part of the scheduler, and we'll see more about that later. So the interface for schedulers includes 3 basic operations plus the clock. So now is the clock here, which allows you to get back the current time according to the scheduler. You can also ask the scheduler to do a piece of work. You give it an action, and it returns you back something that allows you to cancel that action. You can ask it to also do work at a relative time from now, as well as an absolute time from now. And this is the general interface. Now what we're going to do now is take this interface and apply it to a number of different circumstances. So for example, right here we use scheduler.threadpool, which is an instance of the iScheduler interface, but it's actually using the threadpool version of it for the execution environment and for the execution policy, that kind of thing. And it uses the local machine's time as the clock. So here we have an operator range, which is very similar to the range operator in enumerable. So we say, range 1 to 10 is going to have a sequence of 10 numbers. But since we're creating these sequences out of thin air, we have to say, well, where do we want this to run? By default, it'll run on the current thread scheduler. But in this case, we passed in the thread pool scheduler. So we'll be pumping out messages from the thread pool. Then what we do is we take this, assign it to X's, and we filter out so we only have the even numbers, and then we make it we negate the values and we pump them out.
And the console write line here will be running on the thread pool, right?
Exactly. That's right. And so we write these operators. This is kind of the operational level. We declare these high-level queries. Now this is not exactly what Rx does. It doesn't actually translate the code into this, but you can think about it this way, that it kind of lowers your query into a form that's like this, where it's just compositions of observables. In fact, in the very first episode that you looked at, it wasn't the first, I guess it was the second episode, we actually implement observables, and you looked at how they are kind of like events. And you might have seen something like this where you actually implemented observables. But when you write the queries, they start off as queries, but essentially they end up as compositions of observables and of observers. Now, once these compositions of observables are there, once you subscribe, what happens is that it actually goes and uses the schedulers to do the work. Underneath the actual operators, this is what they do. They essentially will be scheduling on a thread pool via the scheduler to do the work. And here you can see like the range 1 to 10 part, and it has like the condition check and so on, the negation. And the self is kind of like the recursive process that allows it to pump through. Now the scheduler is just an abstraction. You can't actually just run a scheduler. Underneath the scheduler is always something else, which is the real concurrency. And so that's actually what happens here. So at the very lowest level, what really is happening in our original query is that we actually have the thread pool queue user work item actually doing the work at the lowest level. So again, with Rx, you start with these high-level queries, and then those high-level queries are kind of lowered into like a query plan, which is kind of like the composition of observables, and then it's executed abstractly via the schedulers, and then they actually do their work via the native concurrency in the system. So there's a lot of different instances of schedulers. Here's a few of them: the thread pool, the dispatcher. An event loop is a dedicated thread. And then there's the immediate scheduler, which means do it right now on the current thread. And then in a remote machine scheduler as well. Now, one thing we ran across when we were doing Rx is that it's difficult to test asynchronous data streams, in particular because of the problem of time. So for example, how do you test a timer that's supposed to happen in 1,000 years? You may have run across this type of thing in your applications. Like if you have a long-running operation, how do you test that in your application, right? In this case, that's a big problem. Another problem is that we have operators that have time-based semantics. So for example, if I create a timer that's supposed to fire every second, and I buffer everything by 1 second, there's actually some amount of, some epsilon that we're off each time. And so when it fires on next, it's going to be at 1 second plus some epsilon. And when buffer actually fires in, it's going to be 1 second plus some other epsilon. And so it's actually erased as where the boundaries are. And so it makes it kind of flaky. Again, you've probably seen this if you ever try to do UI testing on an application, because as you're trying to sense like, mouse moves and user inputs, you're like faking these user inputs. What's going to happen though is that you have to wait for the inputs to happen and check to see if the application responded correctly. But there's some amount of like error about when those things actually happen. And so it makes things flaky. And of course, this is kind of like what it looks like down here when you count for the epsilons. Now, time is the problem, but virtual time is the solution. So if we virtualize time, we can actually execute things more abstractly, and then we can actually solve the problem of time. So another scheduler we have is the test scheduler. And also in conjunction with this, there's also a virtual scheduler, which is the base type for test scheduler. The test scheduler, which is based on the virtual scheduler, is also a historical scheduler as well. And the historical scheduler allows you to like run historical queries over, for example, if you have a bunch of stock quotes from the past or whatever. All right, so testing, here we use the test scheduler, and we do this kind of thing. So we create a test scheduler, and now we want to create some fake input that we're going to test. And the angle brackets seem to have disappeared, but they're right here. And so we have observable string input. We create the observable. Here we have Wes and Bart coming at time 300 from the start of time and 400 from the start of time, and then an uncompleted message. And then we say, run this test, this query, and the query we give it is the input, and we project each thing to its length, and then we assert that the output looks like this. This is kind of how our tests look internally. It uses the test scheduler. We created kind of some extension methods we have privately in order to make it a little cleaner, but when you'll find the test scheduler and the methods you'll find are actually more in line with what you find in the rest of .NET's testing environment. All right. So we'll turn it over to Bart to give us a demo of schedulers.
So let's take a look at, where you use schedulers to parameterize concurrency and how to use them to tame concurrency, if you will. So let's start by creating a new Windows Forms application here. And let's actually do something like updating the UI based on some timer in the system. So let's actually just create a form load event over here. Add a reference to system reactive, like this. And now we can actually create like a timer using the query operators that we have available in observable. So let's do observable.interval, which basically creates an iObservable of long that actually fires every time span that's specified. So let's say I specify a timer for every 1 second, and that will give me a sequence of numbers. Now, instead of giving me a sequence of numbers, say that I simply want to get a sequence of date times because I want to throw some clock, I can simply do something like from, that particular, value I don't care about in the sequence, just project it onto datetime.now. So now I have a sequence of those values that actually will be produced 1 second based on some timer behind the scenes. So as I have that, I can actually update the UI by taking the date and doing something like this.text equals d.toString. Oops. So that will actually update the title bar every second the timer fires. So let's take a look at what happens when I execute this application by pressing F5. Well, clearly something went totally wrong. The application quit prematurely, no sign of what's going wrong. Well, it just turns out that we haven't enabled all the debugging capabilities of Visual Studio here. But typically you have like managed debugging assistance enabled or, first-class exceptions for the CLR. And when actually you enable those things and you press F5, you might see an exception that you've seen plenty of times before when you actually wrote your applications in a UI context. Is this cross-thread violation that you actually have here, where somebody tries to update the UI from the background thread. So what's really going on here is that observable interval is running a timer behind the scenes that's in this case running somewhere in system.threading, which is clearly not the same context as the UI loop. So how do you fix this issue? Well, clearly the source of the problem is that the interval is being produced somewhere else. So how can I make this actually produce on the UI loop by using the UI timer? So the answer is that every operator that needs to introduce concurrency in the system is parameterized by an optional iScheduler. And so here you can actually parameterize this thing by passing in a scheduler from a number of choices. One way to pass in a scheduler is by doing scheduler dot, and then you see a whole a la carte menu of different schedulers available. Like you can schedule things on the current thread to execute them immediately, which is not very asynchronous. It's more like a blocking operation in that case. You can allocate a whole new thread to actually do exactly this, act of pumping some timer. You can also pass in the task pool, the thread pool, and of course we have some meaningful defaults. So how do I make this work now for the UI thread? I don't see UI thread in this menu. Well, the answer is that we have refactored Rx slightly to actually have separate assemblies that encapsulate all the Windows forms, all the WPF and all the Silverlight capabilities. So in this case, since I'm using Windows forms, I'm going to include the specific assembly for system.reactive.windows.forms, which you can also find in the .NET tab of the Add Reference dialog if you haven't used it before. And so this particular assembly contains a scheduler that knows how to talk to Windows Forms controls in order to do scheduling by doing like form.beginInvoke or form.invoke by using, system Windows Forms.timers and so forth. So as I do that, and you take a look at system reactive Windows Forms, you will find in the concurrency namespace there is something called the control scheduler, which is basically a scheduler implementing the iScheduler interface that's actually sitting around some control. So I can say new control scheduler of this, which is my Windows form. And as I do that, this control scheduler will use Windows Forms timers to actually produce this interval. So now I don't have the cross-thread violation issue because the messages are produced in the right place to begin with. So as I execute that, you see that the title bar is being updated. We don't see any exceptions. However, in a lot of cases, you can't control where concurrency happens in the system. Say that you're bridging with like some .NET event for some manageability APIs that might happen on a background thread, or you might be importing like asynchronous method calls to like a web service. You can't really control where those things happen. So let's assume that observable.interval is not parameterized by the right scheduler, and in fact, because things are first class, you could totally envision that this particular sequence that you have sitting here might be coming from elsewhere, right? You might actually have this thing passed into a constructor, for example. So let's actually be bold and actually take a look at how we can do that. Assume you have a timer that you don't control that was passed in through some constructor, and let's not forget to call the base here. And we'll pass in an iObservable of date time from somewhere else, like somebody gives me a clock, which I call the timer. Oops, timer equals timer, like this. And let's generate a backing field. So somebody has passed in a timer to the form. Of course, I would like to do that on a default constructor, but let's ignore that. And somebody is passing in, that source elsewhere. Like in this case, when the application starts, they have to give you that particular timer. Now you can't control anymore where this thing happens. So when you execute this code, you will again see, the cross-thread violation happening here because, well, you didn't control where the timer actually fired. So how do you deal with those sequences that don't work in the right place? Well, the answer is we actually have an operator called observeOn that you can pass in a scheduler. So that's the default overload for observeOn is something you can give a scheduler to run the computation downstream in the query pipeline on. So when you do observeOn and you pass in a scheduler, all the code to the right effectively starts executing in that particular place. So my event handlers would actually be invoked on that particular scheduler. So in this case, I could do observeOn a control scheduler for my particular Windows form, or because I've actually included system reactive Windows forms, you can also pass in the control itself. You don't have to new up a control scheduler. This is just a convenience overload that we have here. So you could observe it on this, which means create me a control scheduler, which basically will observe all the messages by using the UI loop. And so as you do that, you're basically throwing the messages over the wall and you don't see the problem happen anymore. So we have now tamed a sequence with regards to its concurrency. So those are a number of things you can do with schedulers. There are many more places where you see schedulers, like lots of operators that need to introduce time notions, like buffering. Those actually take in optional iSchedulers as well. Things like delay, timestamp, well, not timestamp, but, well, timestamp as well, I believe. So all of those guys actually take in iSchedulers, which are optional. The defaults make a lot of sense. So if you actually need to use them, you can actually just go there and go to scheduler dot and select any scheduler of your choice. And we actually have a lot of our colleagues coming online.
So one other note here is that there's observe on, we've talked about. There's also subscribe on. Don't get confused between the two. And so there's observe on, which basically allows you to parameterize where the on next, on completed, and on air messages run. That's what observe on is. Subscribe on parameterizes where the actual subscribe code runs and where the unsubscribed code runs. Most often, what you want to use is observe on. There are a few cases for subscribe on, but most often it's observe on you want. The challenge for today is actually really fun. So we talked a little bit about virtual scheduling, and the challenge has to do with virtual scheduling. So we have here the fourth challenge, which is schedulers. And in this code, whoops, let's see, it's right.
Slightly in the main form.
Yes. Other one?
The top level, yeah.
Yep, this one, view code. And so there's two places you have to implement code. So there's a bunch of, you will see here, let me bump up the font. There is get quotes, which takes a scheduler and an enumerable of stock quotes. Okay, and what you need to do is basically take these stock quotes and pump them into the scheduler to create a bunch of messages of stock quotes. This is observable stock quote at the right times because they all have date times associated with them. And so you need to use this scheduler as a virtual time scheduler in order to do that. And the second thing is, now that you have an observable stream of stock quotes, you need to do a little query to get the current Microsoft stock price, as well as the date time. When you project that out, make sure that you include the date time as a property with a date time, because that's how it uses it to bind to the x-axis. So have fun. It's a fun little exercise, and the next challenge will actually build off of this. So we've had fun today, and we look forward to seeing you next time.